Hello, everyone. Welcome back to Jump On Air. We're so happy you've chosen to spend some of your Wednesday with us as we talk about statistics, science, data, and of course, Jump. My name is Julian Paris. I am the Learning Strategy Manager here at Jump Software, and I'm your host for Jump On Air. We have a really great show for you, as always, full of great speakers sharing their stories and sharing their knowledge with us. We hope you'll connect with us after the show as we show interesting topics and have them actually on our user community. You can interact with us really anywhere. Sorry. You can interact with us at community.jump.com, really anywhere on the episode pages or anywhere on the show segments. So make sure to connect with our speakers and make sure to show us the things that you want us to talk about so that we can make this show really all about you. If at any time during our broadcast you get disconnected, remember that you can always connect back, jump.com/jumponair, and we'll be right here waiting for you. So throughout the program, I'm going to be referring to our schedule. Wow, my slides are all in a very different order today. I am so sorry. Throughout the program, I'm going to be referring to the schedule, and I'm going to do my best to keep us on track. And that's, of course, because if you disconnect, we want to make sure you know you can come back and see any of the programs you want to see. So again, community.jump.com. Yes.
Are we supposed to see your slides right now?
You are. Thank you, Ross. Wow, this is today a technical difficulties kind of day. Let me share some slides with you now. And you didn't even see what I had wrong. That's maybe a good thing. community.jump.com/jumponair. This is the URL to interact with us. And again, if you go to this page, you can find any of the show segments, look at our full episodes if you want to see anything you missed, and of course, interact with us by clicking on the labels to find the show segments you want. All right. Thank you again, Ross, for that. Now, I always like to start the show by doing a little bit of a segment, and today's going to be a little bit different in a segment that I'm calling Wait, What? Which is a segment about inspecting the unexpected things that occur within our data. And I wanted to do this segment because it came up with a colleague of mine who was working with some data and came across something very strange when she was working with ratios. And so this is a Wait, What? About the confounding case of some mean ratios. And I'm going to pop over to Jump here because I want to give you an example of this particular problem in a slightly different context. And so this is a context where if you imagine we're building a house and we've been buying lumber for this house over a couple different years. And so if we look at this data set, what I have is for data from 2017 all the way through 2019, data on the board feet we purchased for this lumber, the price we paid, and the price per board foot. And if we actually just take a look at these distributions, just so we can convince ourselves that I haven't done anything too tricky with these data, you can see some distributions we might expect. So when we buy wood, we're typically buying around 100 board feet at a time, so 107. The price we're paying for any one transaction is about $3.95. And for any of the transactions, the average price per board foot is about $4.29. Sometimes we're buying pretty cheap wood, down to about $1. And sometimes we're buying very specialty wood at around $9. We have 3 suppliers, Woody's Wood, Timber Tom's, and Lumber Larry's. Whoever made these data clearly likes alliterations. And we have across the 3 different years. And you can see we started off buying some wood, a lot more transactions in 2018, and we trickled off in 2019 as we finished most of the house. Okay, so let's imagine that you are on this construction project and you were asked to produce some reports. So one thing you might want to know is how is the cost per board foot that you're paying changing over time? And so you might think to yourself, well, I'll do this in Graph Builder. We all love Graph Builder. And maybe you'll put price per board foot on your Y and the year on your X. And you think, okay, I just want a simple graph here. I'm going to turn on the bars and maybe even put some labels on by factor. So I want the average price per board foot there. So 387, 441, and 488. And you might actually be a little alarmed by this, that the price you're paying for each board foot is actually increasing over time. And so maybe you think this is some cause for concern. So let's tuck away that graph for a second, because somebody else on your project had confirmed for you recently that there was no alarming trends. And this person had actually done something different in JMP. As there always is in JMP, there's lots of ways to get an answer. This person had gone to Table Summary, a great platform for getting summary statistics, had put in year as their grouping variable, so we have separate rows for each year, and had taken board feet and price paid. And rather than using the pre-calculated variable, had said, okay, no, I'm going to just sum the amount of board feet we've had over those years and the amount of price we've paid over those years. So we have a total for each of these. And so if you look at this data table, we have for 2017, 2018, and 2019, the sum, the total amount of feet of board we've gotten and the price paid. And they thought, okay, I'll just make a new column with the ratio. And if we remember Pete and Mary's segment, new formula columns are great for this. So we'll get a new formula column, combine. And in this case, we want the reverse order because we're dividing the second by the first, price divided by board feet. And this person had come to a slightly different answer. In fact, $3, $3.70, and $3.69, the price didn't seem to change over those years. And I'll just put this in a similar graph so we can look at them side by side. So I'll stick that in there. I'll put year in. I'll put the bars on, and I'll even add the same captions here by factor. And as it always is, it's a little alarming to get different answers different ways, right? Because something is different between these two, clearly, even though they're using ostensibly the same data. And this was the problem that my colleague ran into in a slightly different context. In one plot of these, there was a somewhat alarming trend, the price going up per board foot. That's surprisingly hard to say. And in another plot, the price staying rather the same. Okay, let's hang on to those for a second. I'm just going to minimize them because I want to talk about this problem in a simplified context that will hopefully make the problem really obvious. And so what I have is actually in this table a little simplified example where we have just two transactions. We have a transaction when we've purchased, in this case, 10 feet of board, 10 board feet, and we paid $10. So that is $1 per board foot. And a second transaction where we only purchased one board foot and paid $12 for it. So $12 per board foot. Now, in this example, we can do these averages ourselves. If we're averaging price per board foot on the right-hand side, that's $6.50. So 1 plus 12 is 13 divided by 2, $6.50. If we were to take the sum of how many feet of board we've purchased, 11, and the sum of the price we've paid, 22, well, 22 divided by 11 is 2. 2 is not the same as 6.5, as any keen observer will note. And so the issue here isn't something special about the data table I built. It's that ratios work in a strange way. Or maybe not a strange way, but a way that you need to think about to notice the difference of. A ratio or a proportion is capturing a lot of information, and it's throwing away some very important information. It's capturing the quantity divided by a total, but it's also throwing away what that total denominator was. And in this case, you can see the issue. In one of these purchases, we had 10 times as much wood that we purchased. And so that should count more in some calculation about the price per board foot. And if we're just averaging the transaction prices, well, that's going to ignore how much feet of board we actually purchased. And so the issue is that the transaction average, the one that we did on the first data table, the one that didn't take into account the amount of board feet, well, that is an average that means something. It is literally the average transaction price per board foot, but it's not really the amount we paid per board foot. To do that, we had that summary. We summed up all the board feet we purchased and had the price divided by that. All right, so there's one thing I had to do that was a little tricky here, which was in building this data table, and I'll actually build this for you, I had to impose a particular statistical paradox to make the effect this crazy. I actually basically imbue the data with Simpson's paradox. And I'll show this really quickly, and then I'll show you the fix for actually graphing these data. But the issue was, if I take supplier here and put it as an overlay, and just so it's so obvious, let me right-click and swap that with year. What I've actually done is created a paradox where if we look at the within supplier, cost per board, I can't do that, cost per board foot, it's actually declining within each supplier. But the way I've crafted the data is the overall trend, the trend not looking at a broken apart supplier, goes in the opposite direction. And that's Simpson's paradox, and we can have a discussion about that at a later time. All right, so what's the fix here? The fix here is to have a graph that takes into account that denominator, the fact that the board feet is differing for each transaction. And there's a lot of ways to solve this. One is pre-summarizing using the table summary platform. The other is using that frequency rule. If I put board feet into the frequency rule, it will essentially multiply each of these transactions by that back weighting it to the number of board feet. And so these calculations, 353, 373, and 370, match what we would get if we were to pre-summarize. So there is a way out of this, but it's important to recognize the difference between that average ratio and the ratio of the totals that we eventually calculate using summary. All right, so that was the confounding case of some mean ratios. Now, we'll come back and talk about Simpson's paradox at another time because that's actually a very interesting thing. But remember, when you're working with ratios, you have to be careful of the denominators being equivalent. Otherwise, you can get into some strange situations. All right, so that was this edition of Wait, What? All right, so we do have a great show for you today, and I'm really excited about some of our speakers. Our first speaker is Aurora, who's going to take us through software development in JMP Live. And Aurora is actually a developer on JMP Live, or a senior software developer, in fact. And so I'm very excited that she's going to join us on the program to talk a little bit about the development of JMP Live.
Hi. Am I displaying my screen correctly?
You are. You look great.
Great. Thanks. I couldn't see that on my view. I'm Aurora Tiffany Davis. I'm a senior software developer on the JMP Live team, and I want to talk to you about how we develop software within JMP Live here today. If you have any questions, just type them in the Q&A, and I'll try to take a look at those at the end. Okay, so first I would like you to imagine what software development looks like. If you're not a software developer yourself and you don't work directly with software developers, then your imagination might be fueled by TV and movies, and you might be picturing someone working alone in a room. That person might be a bit of an oddball, and they might even be a genius. But in real life, it's quite different than that, at least in JMP Live. We do not work alone, we work very collaboratively. And although some of us might be oddballs, none of us are geniuses. Because we're not geniuses, we cannot write 100% flawless code on our very first try without talking to anybody or really even understanding what the problem is. And because we live in the real world, we need a process. And it's that process that I'd like to talk to you about today. This flowchart shows a rough outline of what our software development process looks like within JMP Live. And this process could vary across companies. It could even vary within JMP in terms of the exact steps followed and the tools used. But this is a rough picture. I'd like to walk you through this process starting at the left-hand side here on Find a Need. And what do I mean by find a need? I mean, why are we even going to sit down and write software to begin with? It's because a customer has a need for a new feature, or maybe they have an issue with how our software works currently, also known as a bug. So we need to track what those needs are. We use a system called Jira, which is industry standard, very widely used, has a lot of great graphs and different ways you can slice and dice the information to figure out what we want to do and who's in charge of it and when it's supposed to be done by. Okay, so now we know that we have some need to sit down and write software. What do we do next? Do we sit down and write code immediately? No, first we try to understand, okay, what's really needed though? And the first part of that is talking to people. That is the first and possibly most important part of any of the steps of our process. We want to understand what is really needed. Why does the customer need this? How are they going to use this? That kind of thing. So we talk to people. The other thing that we might do is we might actually run JMP Live on our local machine or on one of several servers that we have in the office. We might also open up our development environment and poke around in the code itself to better understand what the need is. Okay, so we know that we need to write some code, and we think we understand that need pretty well. The next step is to figure out what we're going to do about it. In other words, design a solution. Again, the first step here is talking to people. We talk to each other not only within the development team, but we can also draw on the expertise of others in the JMP group, such as user experience experts that we have in JMP. We want to make sure that we don't reinvent the wheel. So we might be having an issue that 1,000 other people have had that's not specific to JMP Live. Something like how to do logging in the background for tech support to look at later. These are problems that if a lot of people have had them, there's probably already a pretty good solution out there. It's probably pretty mature, pretty stable, and pretty good. And that means we should use it instead of spending a month writing it ourselves. So we do use open source software solutions. We do carefully vet them and make sure that they're safe to use and that kind of thing. Of course, that still leaves an awful lot of code that is specific to Jump Live that requires a custom solution. And when we're designing those, we might be writing articles that go in our internal system so we can share around. We might be drawing on whiteboards. We might even be getting into the nitty-gritty of how different pieces of our software talk to each other by writing specifications. We just want to make sure that everybody is basically on the same page about the direction that we're going. All right, so now we have a pretty good idea of how we want to solve the problem. The next step is actually sitting down and writing code. And again, if you watch movies, you would think that this is the entire process right here. When we sit down and write code, the tool that most of us in Jump Live use is a tool called WebStorm. That is a development environment that is very mature. It's very widely used, and it has lots of bells and whistles, lots of features to save us time and save us typing. However, there are many other good solutions out there, very mature solutions for this. And if somebody on Jump Live wants to use one of those instead, then they're perfectly free to do so. We don't want to constrain anybody. We just want to provide good tools for people to do their jobs. All right, so I've written some code. I think it's great. I should just check it in, right? No. The next thing that I do after writing code is to try to find the problems in the code that I've just written. There might be problems in there, and if I don't find them, then the user will. And I don't want that. So the first step is I want to find the very obvious problems. And to do this, we use a static analyzer. The one that we use is called ESLint. There are others out there that are more applicable to different programming languages. But static analyzers all work in basically the same way. And what they do is they look at your code without actually running it. That is to say, they look at your code as though it's just written on a piece of paper. An analogy might be Microsoft Word. When you write a document in Microsoft Word can tell you, I think you misspelled this word, or I expected to see a comma here and I don't see one. Is that okay? Static analyzers are like that, but for code. They can find some of those obvious problems. Okay, so when we go through that and we fix any errors that might have been found that way, the next step after looking for very obvious problems is to look for slightly less obvious problems. To do that, we have an automated test suite. And ours happens to use a library called Jest. Just like Static Analyzer, there are other tools out there. We use Jest, and having an automated test suite has been really beneficial to us. One reason is that the simple act of sitting down to write a test can often help to refine our thinking about exactly how our code is supposed to work in the first place. Another reason that automated test suites are really helpful is that if I fix a bug today, I want to make sure it stays fixed. And having a test that looks for it is helpful for that. Another thing is that if I write code for a new feature today, I want to make sure that I haven't just broken somebody else's code that they wrote 6 months ago. So having a broad range of tests can help build confidence and catch problems early. Okay, so we found very obvious problems and we found slightly less obvious problems. The next step is to find even less obvious problems. And for that, we do some manual testing. We might run Jump Live on our local machine, or again on one of several servers that we have in the office. We might open up a database administration tool, which is a tool that can look at what's going on in the database that sits behind Jump Live and keeps track of all the information about posts, users, groups, that kind of thing. We might want to look at exactly what records are getting written, where, when, and how. When we do this manual testing, regardless of what tool we use a very sophisticated, very intelligent technique for this, and it is called poke around and try to break stuff. And it can often be very helpful. Okay, so I have written some code, and I've gone through several steps to try to reassure myself that it is good code. And during these activities, I may have found a problem and fixed it. I may have gotten a new idea of some different way to solve it, or some tweak on it, some better way to solve it. And now I think it's pretty good. But the next step is not to check it in. The next step is to, again, try to find more problems. And this time, I want to see if there are any problems in the code that I can't see, but someone else can see. And for that, I put the code through peer review. Now, why would there be a problem that I can't see, but someone else can see? One reason might be simply that I've sort of gotten into a rut with my thinking, or I've got my blinders on about something. Another reason might be that I simply lack knowledge that someone else on the team has, whether that is knowledge about a particular technique that I could be using, some way things could be more efficient, or some subtlety of how Jump Live software works. So we get a lot of value out of peer review. And it is helpful not only for finding bugs, but also for coming up with new suggestions. We sometimes get comments in there like, hey, this is great, but you know it would be even better? Or, hey, great, this is good, but it reminded me about this new feature that I had heard somebody talking about in the hallway. It just spurs conversations, and that's really helpful. Another thing that's good about peer reviews is that it doesn't just help the person who's getting their code reviewed, it often helps the reviewer to learn new techniques or to learn different subtleties of how the Jump Live software works in areas that they might not work in day to day. We actually put 100% of our code through peer review, and it is because we view it as an investment rather than a sunk cost, which is to say we think we gain more time out of it than we lose, and that's why we do it. Okay, so we have gone through peer review, and we are pretty optimistic that this is good code. Now we check it in. We check it into our source code repository. And this is a pretty straightforward step, but there is one little wrinkle to it. We like to remember the saying that documentation is a gift to your future self. And keeping that in mind, we want to make links between different things in our internal systems. So we have the code commit itself in our source code repository. We have the review that preceded that commit. And we have the issue tracker issue that caused us to want to sit down and write code in the first place. And we create links between each of those, so that 6 months from now, if I or somebody else lands on one of these internal systems and is looking at a record, we can easily find the other records that are also associated with the same code change. That's really helpful because there are often great comments in there about why we do certain things, and also other comments about why we don't do other things. That's sometimes just as useful. All right, so we have committed the code. That's it, right? Not quite. There's a few more steps. The fact that we committed the code is picked up on by what's called a continuous build system. The one that we use is called Bamboo. There are others out there. The first thing that our continuous build system does is it reruns the static analyzer, and it reruns our full automated test suite. Now, these are steps that we should have already done earlier in the process before we ever checked in code, right? Well, yes, but we're only humans. Sometimes people forget things. Another reason that the continuous build system does this is that it is possible for there to be an issue that I can't cause to happen on my local machine. Maybe because I have my local machine set up just so. I have it just the way I like it. And things work when it's set up like that. And then it gets to Bamboo, and some test fails. It can just be helpful to have it run on another system that is set up differently as a way of checking more different scenarios. Another thing that is really helpful about a continuous build system is that it can show you trends in your project. For example, trends over time of how big your project is, what is your success and failure history with building, and also what is the amount of coverage that you're getting with your automated test suite, which we're hoping to improve all the time. When it makes it through this step, and it then becomes available to other people outside of development. The first people that pick up on it outside of development are the test professionals in our test group within JMP. Why are they testing stuff? Didn't we already test it? Well, yes, we did, but they are testers. That's their job, and they're really good at it. They have expertise that we don't have because this is their career. And also, they just have a different perspective than we do because they're not sitting there writing code all day long. And so that different perspective can often be really helpful. They find a lot of stuff for us. And the first thing that they do, which is also the first thing that we do in a lot of our process steps, is talk to people. They talk to people to understand more about what has changed in the code and why. They also very often will add to our automated test suite to make it better and better over time. They will test on a variety of different devices, on a variety of different browsers. And they may even use a tool like the one that's shown here, which is called Sauce Labs, which allows you to select a combination of different device types, screen resolutions, operating systems, and browsers, and find out how Jump Live looks and how Jump Live behaves in different scenarios. Once it has made it past our test professionals and we fixed any issues that they have found and created new issues in our tracker for any great ideas that they have, because sometimes they will also come up with comments like, hey, now that I see this, it's reminding me we really ought to do something like XYZ. So after we've gotten all those advantages out of the test by professionals, Now the software is going to move on and actually be ready to be picked up in a release cycle. So let's zoom back out here and look again at this process that we've gone through for a single feature or for a bug. And one thing I'd like to point out about this process is that this is a scaling process. It doesn't actually look the same for everything we do. So there are some bugs that are very straightforward, very easy to understand. You know, I can knock it out in 10 minutes, kind of a thing. For that, we still go through this process because we're human and we know we can make mistakes. But we're going to go through each step in this process pretty darn quickly. On the other hand, there are some new features that are very complex and very challenging. Again, we're going to go through this process, but in that case, we're going to spend a lot more time on each process, making sure, on each part of the process, I should say, making sure that we get it right. The other thing that this picture doesn't show you is that there are other activities that go on a periodic basis. For example, once every couple of months, we do something called white box testing, which is where we take a day and all of the JMP Live developers devote this day to using JMP Live as a user would use it and looking for problems and looking for new opportunities. And what we do here is I will look at features maybe that aren't the features that I work on a day-to-day basis. And someone else might be looking at the features that I do work on a day-to-day basis. This is really beneficial. We find issues and we find ideas for new features by doing this. We also consider it a really great cross-training opportunity because it helps us to better understand areas of the code that we don't get into on a day-to-day basis. The other thing that's really helpful about this white box testing is that it gives us a really useful user perspective on the product. Okay, so I just talked about a whole bunch of stuff that we do. Why do we do all this stuff? It's time consuming. And anything that costs time costs money for a company. So why is JMP willing to invest this money? One reason is simple pride in our work. We want to produce a good product. The other reason is that we know if there are problems in there and we don't find them, our customers will, and that is not good for business. And we do it because we view it as an investment. We think we get more out of it than we put in, and that's why we do it. I should point out, however, that while JMP invests money in this process, it does not invest as much money in this process as, for example, NASA would. So we don't promise absolute perfection. We just strive for quality. And JMP Live, like any other piece of software out there on the marketplace, is going to have something that you don't care for about how it works. And you can really help us out, and we would like to ask you to help us out by going to www.jmp.com/support and report any issues that you see or any new features that you might like to see in JMP Live. That feedback from real users is very, very helpful for us, and we really appreciate it. Now I would like to take a break to check the Q&A and see what is going on there. And I don't know that I can see that from my current view, so I'll have to ask Julian to jump in and let me know if there are any Q&A questions.
Yeah, Aurora. There aren't yet. I can do a quick 2-minute pause to give people time to ask some questions if you like.
Well, I also have a separate topic. If we had extra time, I was going to hope to sneak in. So.
Oh, yeah, sneak it in. That's
Okay,
great.
great.
Yeah, if anyone does have questions, go ahead and put them in the Q&A. But yeah, go on ahead.
Okay, fantastic. All right. So, oh, there. Now I see how to get to the Q&A, of course. Sorry, it's my first time on one of these. All right, so the next thing I'd like to talk to you about is a little extra topic. I'm going to sneak in here. So I got curious. Like many of you, we are working from home now in JMP. And I was really curious about what working from home was going to do to our volume of work. So I pulled some data out of our source code repository. And I looked at it and I graphed it a couple different ways using JMP, of course. And this first graph shows the number of times for any given day over the last year that code was checked in. And this is across all of JMP, not just JMP Live. So again, this graph shows you for any given day how many times somebody checked code into our repository. It's a very spiky graph. You can see it go up and down a whole lot. The parts that go down are usually going to be weekends or vacations. We started working from home in mid-March, which if you can see my cursor is towards the end of the graph here. In mid-March of 2020 is when we started working from home, and just looking at this graph, I can't really discern anything major about when we started working from home in terms of the volume of our work. I was kind of surprised by this. I was expecting to see us falter and then recover, but I can't even really see us falter on this graph. But I was still curious, so I thought I'd look at it another way. I thought, well, okay, maybe we're doing the same amount of work, but surely we're doing it at weird times of the day. So I looked at it that way. This is time versus date, again, over the last full year across all of JMP. And you can see that we are clustered pretty tightly from 8 a.m. to 5 p.m. with some outliers as expected, and with a pretty light band here around noon when people take their lunch. If you look here again at mid-March 2020, there really isn't a big difference that I can see. One thing I think I can detect is that we aren't all taking our lunch at the same time and trudging down to the cafeteria. Instead, we are staggering our lunch hours a little bit, maybe depending on what's going on in our homes. I was still curious, so I thought I'd look at it one more way, which is day of week. So maybe we're working more on Saturdays and Sundays. This graph shows that data, and day 1 here is Sunday, and day 7 is Saturday, and the rest of the days are weekdays. Again, if you look at mid-March, nothing really jumps out as having changed around mid-March. The reason that I really like this graph is that it is very clear when our work has slowed down on holidays. For example, you can very clearly see July 4th, you can see Labor Day, you can see Thanksgiving, and you can see our winter break between Christmas and New Year's as being very obvious times when work slowed down radically. And you don't see that at all in mid-March. So again, these results kind of surprised me, but I'm really pleased by them. And I think it just shows that here at JMP, we are continuing to work hard on creating new features that will benefit our users. If there aren't any questions, then let me check in the Q&A here. I'd like to just thank you very much for joining us. And I hope that you have a fantastic rest of your day. And I will go ahead and pass it back to Julian. Thank you.
All right, I do see 1 or 2 questions I can ask you if you want. Maybe just one you can comment on, which is for those of our users who write their own scripts or add-ins, general recommendations, yeah, for code checking.
Yeah, so as far as I know, there is not a static analyzer for JSL, although that could be something that exists that I don't know about. I would say that if you don't have the support for JSL that you would have for a language like C, which millions of people use, such as the static analyzer that's designed specifically for it, then I would encourage you to maybe try to write your own tests. So you could have JSL scripts and run them against several different data tables that you keep around, and make sure that when you update your script, it still produces the results that you expect against these several different data tables. That would kind of simulate what we're doing with our automated test suite. Another thing is if you have a peer that understands your domain and understands JSL, peer review is like very, very useful, and you don't need any specialized tools for it. We use a tool called Swarm. There are other tools that are available that have free plans for small companies and for individuals. You could use a tool like that. You could use peer review in terms of, hey, let me send you the script, let me know what you think about it over email. Some of the tools are really helpful for doing peer review, but just the fact of doing it uncovers really a surprising amount of issues. So I would recommend that if you have the time to devote to it. I see another Q&A question here that says, this is an excellent process. Is it outlined somewhere? I don't think it is documented anywhere on our JMP community, but I'm certainly happy to add these materials anywhere that people would find them useful for future reference. There is another question here that says, in what language are the tools primarily written? And so I mentioned a whole bunch of different tools, and I don't know the answer for most of them as to what language those tools themselves were written in. I assume you're asking about some of the things that I mentioned, like WebStorm, Jest, Bamboo, and so on. And the simple answer to that is I don't know, but I'm happy to look it up and put the answers on the community post for this presentation. I'm going to keep kind of scrolling through here until Julian cuts me off. How often do you design experiments to test your code for different customer environments? Conflicting OS, other software, etc. So over changing noise. So I don't have the answer for that off the top of my head. I would have to actually ask our test group, who are a lot more methodical about testing those different scenarios. I know that some of them will do things like one tester will be using one browser and a different tester will be using a different browser, and then on a weekly basis they kind of shift around and change that. As far as design experiments, if you mean that in the highly technical sense of design of experiments, to make sure that all scenarios are covered in an efficient way, I don't know if we do actually DOE for our software testing. But I will try to get back to these Q&As and answer all the ones that I don't know off the top of my head on the community forum.
Yeah, that's probably a good place to stop, Aurora. And yeah, thank you so much for taking the questions, and thanks so much everyone for putting them in. I'll grab the screen back here again, and yeah, for those of you who didn't get your questions answered, we're going to take those over to Aurora's community segment page, and so we'll have the conversation continue there. And thanks again, Aurora. That was really interesting. Our next topic is going to be another installment of Help, where Ross Matusalem takes us through different pieces of help in JMP software.
Hi, everybody. Welcome to another edition of Help, our review of the help resources in JMP and how to use them effectively. I'm Ross Matusalem, Systems Engineer. Today we're going to look at the Scripting Index, which is an excellent resource for getting the most out of JMP scripting language if you know how to script, or as we're going to see right now, even if you don't. For those who aren't familiar, JMP scripting language, or JSL, is a great way to extend JMP's functionality or to automate some of the things that you would normally do in JMP's point-and-click interface. Right now, we're going to look at an example of customizing a script that JMP produced for us automatically to get it to do something that we want. So let's take a look at this data table. This is a data table that I have imported through the Excel import wizard. If you've used any of JMP's import wizards before, you have probably noticed that there are tools where you can enter information to specify the formatting of that file so that JMP imports it correctly. And this is one of the places where JMP produces automatically for you JSL scripts. Here we have the source script in the data table. I'll right click and select edit so that we can take a look at what's in there. So you can see we have an open command where JMP is saying, oh, I want to open this file, and then apply all of these settings that I had applied through the Excel wizard's point-and-click interface. So this is a great script that I can use to import other Excel files that I have that have the same formatting as the first one that I imported. I have one of those Excel files here on my desktop here. So you see I originally imported a file from December 2019. Here's one from January 2020. So I want to use this script to import the January 2020 file without having to go through all the pointing and clicking in the Excel import wizard. Simple way I could do that, maybe I'll actually just copy paste this file name into my script. Now I'm doing this in the table script. Normally I would copy this out to a separate script window, but for our purposes here, this will be okay. So I've put that in, and if I click run, JMP imports that January 2020 data file. So this is great. I've basically automated, in a way, Excel importing for myself. But this doesn't scale that well. You know, this requires me to copy paste or to type in which file I want to import. And I would rather have a solution where JMP presents me with a file open window where I can just point to the file that I want and run the script on that. So that's something that I should be able to do in JSL, but I don't know how. So need a little help. Let's jump to the scripting index to find some more information. So you'll find the scripting index under Help, Scripting Index. Let me unpack what we're seeing here. In this middle column, we have a bunch of different commands in JSL, and on the right, we get a bunch of information about those commands. On the left, we can view these commands by different categories. We want to operate on a file, so I could scroll on down to the file section here and see all the different commands that operate on files. I'm actually going to go ahead and just type something into our filter here to try to find what we're looking for. I want an open file window. That's what I want to be presented with. Let's see what it pulls up. Well, I get a number of matches. Let me go ahead and filter down a little more to say, just give me the ones that operate on files. I got 3 matches. All right, open, pick directory, pick file. No, pick file sounds like what I want to do. So I'm going to go ahead and take a look at that. Up at the top here on the right, we see the syntax for using pick file. Then we have a simple description here, where if you notice at the beginning, it says that it prompts the user with an open window, returning the path name of the file. Kind of sounds like what I want to do, but I want to learn more about how to use this pick file command before putting it in a script. Down here, I have some example JSL code that I can run to see how this works. So let me go ahead and click this button to run the code. That pops up this file open window that I want. Let me go to the desktop and actually just point this right at that January 2020 file and click choose and see what happens. So we're done. If we look down below, we can actually see what JMP did. It ran this pick file code, and this is what it produced. Here we have a text string that looks like where that file's living in the file name, which corresponds pretty cleanly with what we actually want in our script. So it looks like pick file is going to produce what we need. So it's good to go to plop into our script. But before we do, I actually want to learn a little more about pick file. I could go to the topic help, which will take you to the help documentation online. And if we were to go there, for the sake of time, we won't. You'd learn that it says all of the arguments here, all this extra stuff that maybe I don't totally understand, is optional. Now, one nice thing about the sample code that's put here in the scripting index is that it's editable. You can tweak it and then run that code in this little kind of sandbox to see what it does. In this case, I'm just going to delete all this stuff. Maybe I don't even need it. So let's just run a bare pick file. So I'll run that again. And lo and behold, I get my file open window. I'll point to that file. When I click choose, it still returns what I'm looking for, so it looks like we're good to go. And because I'm feeling a little lazy, I don't even want to type pick file out. I'm just going to go ahead and copy that and paste it right into my script. Now, if you write JSL, you probably think this looks a little funny, leaving this semicolon in here and all that, but this should work for our purposes. So I'm going to go ahead and click run. All right, it's letting me point to a file. I'll point to that January 2020 file. Runs it through the Excel import wizard without us having to click anything, and now I've imported a brand new file. So I've been able to use the scripting index to figure out what I needed to tweak this pre-existing script just so that I can now kind of have a custom data importing tool. And I did that without writing a single line of code. Instead, I was able to efficiently search the scripting index using the groupings and the filter to find this command that I wanted. I read a little bit more about it. I actually experimented with the code in our little sandbox down here. And then I was even able to actually just copy and paste some of this myself. So take-home message, JSL, really powerful tool for extending JMP's functionality and for automating your workflow. And the scripting index, a powerful resource to help you get more out of JSL than you might otherwise. So that's it for help. Julian, back to you.
Outstanding. Thank you so much, Ross. In our next segment, we're going to hear again from our resident Dr. DOE, this time Dr. Brad Jones, who's going to take us through designing experiments for mixed models.
Hello, I'm Brad Jones, and I'm going to talk to you in my role today as Dr. DOE about designing optimal experiments for mixed models. Mixed models are models that have more than one source of variability. And the simplest kind of mixed model would be a random block design, which is the first item in my journal here. So I'll just open this one up, and this is a textbook about design of experiments that just came out in December with myself and Doug Montgomery as authors. And here is an experiment in that textbook. It's called, it's a filtration experiment, and it has a filtration rate, which is the Y variable for the experiment, but the four factors in the experiment are temperature, pressure, concentration, and stirring rate. But there is also a random blocking variable. Half of the runs are done in one setting of the block, and half of the runs are done in another setting of the block. Might be the case that the random blocking variable in this case would be half the runs are run on day one and half of the runs are done on day two. Or it might be half the runs are done using one supplier or one batch of material, and the other half would be using another batch. If I do my if I click on this DOE dialog, it shows me how to set up an experiment with a random block. Here are my factors that I talked about before. If I want a random blocking variable, to add a random block, I just check this box and say how big the blocks are, and then how many runs I'm willing to do, and click Make Design. And I get the same experiment that I just showed you the table for right here. So that's a very simple way of getting a random block factor into an experiment. And that's the simplest kind of mixed model dealt with in JMP. The next, I have 5 different examples that I want to show in this time spot. So the next kind of experiment that I want to talk about is a split plot design. Split plot designs are designs with a random blocking factor, but one additional functionality or feature, and that is that for each level of the random blocking factor, there is one or more factors that stay constant within that block. So a split plot design has that feature, and it also appears in this chapter on split plot design. It appears in this book. Let me show you an example of a split plot design, and you may notice that in the first whole plot here, the temperature is staying the same for all 4 runs in that whole plot, and the same thing is true for all 6 whole plots in this experiment. The temperature here is staying the same within each 4 runs of the experiment. Let's look at a graph builder to see what's going on. We can see that the temperature is changing across each of 4 coatings that represent the corrosion resistance that is being applied. And so now we can, split plot designs require a different kind of analysis than ordinary least squares. If you were to fit the ordinary least squares model to this, you would get, you wouldn't get this Rimmel variance components analysis. You would only be fitting you would only be getting the parameter estimates for the coating and the temperature and the 2-factor interaction. And it turns out that if you don't use the Rimmel analysis, then you can easily make poor inferences. So fortunately, when you make a split plot design in JMP, you get the correct analysis built in and into the data table that gets created when you've designed the experiment. So that's a split plot experiment. The next kind of design I want to talk about is an additional feature of the split plot experiments. Suppose you have a hard to change factor and then a factor that's even more hard to change, so that you have two random blocking factors with factors that are associated with them that are either hard to change or very hard to change. This is a paper that Peter Goss and I wrote on creating optimal designs for split plot experiments that was published in Biometrica in 2009. And let's look at a cheese experiment. We have two factors that are very hard to change, and then we have one factor that's hard to change and another factor that's very hard to change. And there are three kinds of factors here. There are these factors here, the W1 and W2 factors, go with the whole plots. So for instance, the first whole plot has 4 runs, and you can see that both W1 and W2 stay constant for those 4 runs. The factors S1 through S5 are going with subplots, and they stay the same for each subplot of 2 runs. And then we have 2 factors that are easy to change, and they can change between any pair of runs. So the DOE dialog for this design let me back up to defining the factors. There are 3 choices that you can make. You can say that a factor is very hard, which is to change, which is this W1 and W2. You can say that a factor is hard to change, which is true of S1 through S5. And then finally, you can say that a factor is easy to change. So this is often a useful thing to do when you're dealing with a process that takes has more than one stage, where the first stage of the process might be all very hard to change, and then the second stage would be just hard to change, and finally any further stages would the factors would have to be easy to change. So the next kind of design I want to talk about is a strip plot design, and this design actually appears in this book that I wrote with Peter Goss from Belgium, and we describe a battery life experiment. And in this battery life experiment, we have a factor. We have factors that relate to the creation of the batteries, and then another factor which is which of 6 rooms the battery would be tested in, where the rooms are set to high temperatures to try to make the batteries fail. And so you can see that the rows and columns have different orderings. So a strip plot design is a design where you have to be able to re-randomize from going from one stage to another. So in this case, you make all the batteries first using one randomization scheme, and then you test them in different rooms using another randomization scheme. And just to show you how this would be done, you could say, I have, let's say I'm going to have 3 factors to make this clear. I'm going to make x2 be hard to change and x1 be very hard to change. And then I say how many times I want to change the very hard to change factor, how many times I want to change the hard to change factor, and finally, how many total runs I'm willing to do. And then if I can say that the hard to change factors can vary independently of the very hard to change factors, if I click that button, then I get a strip plot design instead of a split plot design. And so you can see that within each whole plot, I'm going to use a different subplot setting. So you can imagine I make all these six different kinds of batteries first, and then I put them in a different room for testing. So that's a strip plot design. So we get to the final example, which is an example which is not at all obvious how you would manage to do a design for 2 nested random block factors or 2 crossed random block factors. So and I wrote a blog on this, which you can. This is the URL for the blog. So here's what you need to do in order to do it for 2 random blocking factors. Is you have to trick jump into making such a design, and you do that by creating a factor that you're not really 2 factors that you're really not going to use. So to illustrate this, let me choose this design setup tool. It's a script that just creates the situation I want. And you can see that I've created a fake whole plot factor and a fake subplot factor. So I've set this up as if it were a split plot experiment. But now I'm not going to put these 2 factors in the model. So I'm going to remove them from the model. And now I don't have any whole. Well, I'm not using the whole plot or the split plot factor in my model. So now I'm going to have 3 whole plots, 6 subplots. Let's make it 4 whole plots and 8 subplots, and then I'll do 32 runs. And then maybe, well, so you can see that these fake factors are being set to just random quantities. They're not important, but I have a whole plot column and a subplot column in my data table, or in my table in JMP. When I make the table, I can just select these 2 fake factors and delete those columns because I'm not going to use them. But there's demographic information about these columns, and one of the so the design role of a whole plot factor is that it's a random blocking factor, and the design role of the subplot factor here is also a random blocking factor. So now I've created a design that has 2 random blocking factors, and I use the template for a split plot design to create this design for 2 random blocks, where one of the blocks is nested within the other block. So that's completely an obvious way to make this happen. So I wrote a blog about it to show how it's done. One of the development goals for a future release of JMP is to have a much more natural interface for creating mixed model, identifying mixed models that have more structure than any of the ones that I've talked about today. And particularly, it would be nice to have a very natural interface for dealing with more than one random block, as we've done here. So that's my presentation for today, and I could answer questions, but I don't know where to find the the Q&A. This is my first time too, so I'm in the same situation as Aurora was.
We'll probably leave those for the community. We're just at time. You gave a perfectly timed presentation, Brad.
One thing that I wanted to add is to answer one of the questions that Aurora got, there is a tool in the DOE tools for JMP called covering arrays that are used very extensively in software quality assurance. You might want to use a JMP On Air demonstration for that at some future date.
Absolutely, Brad. Yeah, I think Joseph even reached out about potentially having them on to talk about it. Covering arrays are quite interesting. Yeah, well, thank you so much, Brad. That was really interesting, and we'll definitely share all your materials with our users at your JMP On Air episode page. I hope we can make your journal available, and we'll definitely put out links to your blog and also links out to your book. So thank you again for being on the show. Our next segment, we're inviting Ryan back to give us another edition of Have You Tried, where he's going to take us through multiple file import.
To import multiple files in JMP, first place the files that you want to import in the same directory. In this demo, I use the import data found in the JMP Samples Import Data folder. Under the File menu in Windows, I'll select Import Multiple Files. On a Mac, it's File Open Multiple. I'll browse to select the Samples, then Import Data folder. All the files show up here in the Files Preview window. Now we need to set which type of files to import from that directory. I'll choose Select File by Name or Extension, and then type in UN, the wildcard, .csv. So this selects anything that starts with UN and ends with CSV. Then press Enter. If I do add different file types, my Files Preview window will adjust to show which files will be imported. Keep in mind you can also add multiple file names. I'll toggle on Stack Similar File Types and keep Data Type toggled on. Now I'll select Import. And the result is one stacked data table from those selected data tables. Again, you can save the import settings as a script and then run that script when the data is updated in the future. Remember, you can practice this with the included import data folder in the JMP Samples folder. Thanks for choosing JMP.
Outstanding. Thank you so much, Ryan. Our next segment is actually one that we've never tried before. It's going to be an analytic guessing game, Masterpieces of Literature. So our next featured program, Senior Manager Chuck Boiler, is going to take us through a little bit of a game.
All right, thank you, Julian, and welcome to the first installment of Masterpieces of Literature, an analytical guessing game. I hope that you'll enjoy this, have a little bit of fun with this. I have perhaps 4 or 5 of my colleagues joining me today, and I'll ask them to go ahead and turn their cameras on and turn and unmute. And what I'm hoping they'll do first is introduce themselves, their role at JMP, and maybe a little bit about their background. And also, if you don't mind telling the audience where you live. And we'll start with Rob.
Hi, Chuck. Rob Levency. I work for the federal civilian team, and I started with JMP last year. Before that, I was in research and development for pharmaceutical, and before that, quality management. And right now, we're having snow today, so it's an interesting day.
And where are you?
Oh, Michigan. I'm sorry.
Oh, awesome. Great. Thank you. And we'll take Ross next. Ross.
Hi everyone, Ross Matusalam, systems engineer in the southeastern US. I'm based in Tampa, Florida. I'm a cognitive scientist by training, and before joining JMP, did research for an education technology company.
Oh, awesome. Yeah, welcome to the show. Kamal.
Hello everyone, I'm Kamal Alfus. I'm in sunny Southern California, and I'm an applied physicist. And previous to starting at JMP, I used to work with things that fly real fast and make big splashes.
Very mysterious. Awesome. And Wendy.
Hi, I'm Wendy, and I'm based out of Minneapolis. So I support what we call the North Central region. And I guess I've done a lot of things in my career. I started out as a biomedical engineer and then transitioned into applied statistics. So I've worked in retail, I've worked in CPG. Yeah,
consumer packaged goods. Awesome. Welcome to the show. And Jeff.
Hey folks, my name's Jeff Thupton. I am a systems engineer out of Northern California, living in San Francisco. Background is in biochemical engineering, so worked in pharma for a while, went down to sunny San Diego, Kamal, so jealous of you down there, to work for a biotech company down there, and then boomerang back up to the Bay Area to work for a medical diagnostics company.
Awesome. Yeah, well, welcome all of you. Again, I'm Chuck Boiler, and I'm in San Francisco, California, and my original background is actually as a teacher. So thanks for agreeing to play this game. I know that this is the first time through this game for you, and the rules are pretty simple. Each of you is going to go in turn and be exposed to some visuals on screen. And those visuals are a term phrase list, which is a frequency of terms in a great work of literature, a word cloud, where the terms in that literature by frequency are bigger or smaller, and word clouds that are appearing in clusters. And this is using a feature of JMP called Text Explorer. And so what I've done is I've loaded 37 great works of literature into JMP. And I'm going to go ahead and play the game first, so you can see how that's going to look. All right. So with any luck at all, I'm going to start sharing my screen, and it should look like this. The great works of literature turned out to be 500,000 rows of text when it's all loaded into JMP. And I'm going to go ahead and play this. This is book 29, and the term and phrase list is showing up on screen right now. And so in this particular book, the term Scrooge showed up 327 times. And there's a phrase that turns up about 17 times called Mrs. Cratchit. If I didn't know what book this was, I could then go to the word cloud, and this is what you'll see. And you can see here that Scrooge is very big because that term shows up quite a bit. You'll see in all of these, you're going to see this term called Gutenberg. All of these works were pulled from the Gutenberg project, so you're going to see that show up. Then I ran some sort of clusters on these, and they're going to break out one of the clusters will always be the header information that comes from the Gutenberg project, but then you'll see other terms here that are breaking out into things that are sort of associated. So Scrooge, Christmas, Ghost. And if I were to guess this title, I would put it in the form of a question. And that question would be, what is the Christmas Carol by Charles Dickens? All right. Does that make sense, contestants? Okay. All right. Very good. So we'll go round robin for perhaps 1 or 2 complete cycles, and then we'll have a lightning round near the end where I'll explain that when we get there. Okay, so I think the first person in the list here is going to be Rob.
Oh no.
Yeah, we're doing it by alphabet. So
I'll bring some help.
Okay, all right. So here we go. So you can take a peek at the term and phrase list. The word one appears 204 times. Upon 174, the word Martians turns up 166 times. And I'll go down here if this helps. Now,
Boy.
cylinder.
I'm just thinking of Mars and Men, but
yeah, I think Mars is a good hint.
yeah.
Let's try a little further down. So we'll look at the clusters here. So we've got in cluster 4, cylinder is showing up. Red, went.
I don't know if that'd
heat.
be War of the Worlds, but
very good.
okay.
And put it in the form of a question. And
what
ask
is
the
War
author.
of the Worlds? Oh
Awesome.
boy.
Okay, for 15 points. Awesome. Okay, good. Well done. Well done. Okay, next in the rotation, this is going to be Ross. Very, very, very good. So we'll go to work number 2. And Ross, most popular term here, or term is said, and there's bloom.
Okay.
Daedalus.
That's a familiar name.
Yeah. Daedalus. Now, what I could do here is I could actually go to the context for any of these. Ross, do any of these sound familiar?
You know, I'm having a lot of kind of vague impressions here, but nothing's coming up to
Okay,
mind.
so I'm going to right mouse click on Mr. Daedalus because I think you said that sounded familiar. And I'm going to say, show the text. And now you're going to actually see body text where Mr. Daedalus shows up.
Mr. Daedalus snarled.
We could try the clusters. How's that sound?
Let's take a look at the clusters.
Okay, so I don't know if this helps. Steven shows up, Bloom.
Like I said, I was worried about revealing how poorly read I am.
Okay, no worry, no worry.
I got nothing.
Okay, does any generous panelist want to make a guess?
I'm right there with you, Ross.
Yeah, no clue.
Okay.
I don't remember Daedalus, but I'm thinking Flowers for Algernon maybe, but
no, not that one. This is I'll go ahead and let, unless anyone else has got a guess, I'll go ahead and give this one away. This is Ulysses by James Joyce.
There we go.
Well done, well done. Just getting warmed up here. Okay, next one, it's Kamal, and we'll look at work number 3 for Kamal. Okay. And
oh boy.
Yeah. So
it sounds easy.
Yeah.
Yeah.
So look at the phrases. I think there's some good ones here. Spyglass, black dog.
How many guesses can I take?
Cried Silver, John Silver. Skeleton Island.
What is Treasure Island?
Very good. Just and that's awesome. So you've got 10 points. If you can come up with the author, you get another 5.
Who is Alexander Dumas?
No, it's Stevenson. So you get 10 points.
Oh.
Well done. Well done. Very good. Okay, good. All right, next we've got Wendy, and this is going to be work number 4, right? Okay. So time machine.
Is this Gulliver's Travels?
No, good guess, but look a little more. This might help. I don't know if you can see this. I'll make it a little bigger. Panelists want to help?
It depends. Can we use Google?
I know if I didn't have my camera turned on, I would just go over here and do some typing.
Okay, let's try the clusters. Let's try the clusters. Yeah, you definitely have seen a movie.
I'm thinking of Jules Verne.
So you're getting warm.
It's not 20,000 Leagues Under the Sea, but I can't think of the other one.
You're right with the author.
Oh.
You're getting quite close. Okay, Morlocks, does that help? That's in cluster 1.
Time Traveler's Wife or something. No, it's not right though.
Okay, I'll go ahead and give this one. This is the Time Machine.
It is the Time Machine. I was on to say that, but I thought it's just too simple.
No, that's really good. So good try. Okay, so we'll switch to, I think it's Jeff now. And Jeff, we're going to look at work number 5. All right.
Is this like, should we call this show Make SEs Look Dumb?
No, not at all. Not at all. If anything, you'll have a good bibliography.
Everyone in the audience is screaming.
Right, you're probably channeling high school or that freshman literature class. I know I was.
Can I cheat and get my wife, who's got the master's in language arts?
Sure.
I'd like to phone a friend, Chuck.
Yeah, I know, exactly. So Jeff, so does this, so take a look at these. I think there's a really good hint in the phrase list.
Yeah. De Treville sounds familiar, but this is going to be tough. Maybe you can hook me up with one of the phrases for a phrase.
Porthos, and there's some French words in here.
Solo hablo español.
Okay, well, so look at the first phrase. Said
the Artagon. Artagnan.
Okay, you're close.
I'm drawing a blank. It's not the Three Musketeers.
It is.
Oh,
okay,
right.
10 points.
Hey, take
and
a guess.
Get 5 points for the author.
Oh, who's the author of that? That's as far as I can go, Chuck.
Anyone got it? Anyone got the author? Okay, it's Alexandra Dumas. So very good. So 10 points for Jeff. Ding, ding, ding. Okay, back to Rob. Okay, Rob, you're going to look at work or book number 6.
Uh-oh.
Okay. Top term is thou.
Almost looks like something from Shakespeare, like Othello or something, but everyone likewise. Wilt.
You want to go down to
yeah.
cloud? Okay. We can look at the clusters, see if that helps.
My goodness. Wow.
Sophronia, does that help?
I don't think so. This one, I think this one I don't have familiar with. I'll let everybody else give it a shot.
Any other guesses to help Rob? Okay, this might be a little harder. It's the Decameron, Giovanni Boccaccio. Okay, so we'll That's good try, everyone. Okay, we're back to Ross, and we'll look at book 7.
Chuck, we can tell you we're a teacher because even when
I
we fail,
know.
you tell us we did a great job.
Oh no, you're totally doing a great job. Hey,
0 points for you, but
this isn't easy, and this is not easy. I've been staring at these for a week, and it gets easier after you stare at them for a week. Okay, so Ross, we're looking at number 7 here, and
okay. Socrates.
okay, yeah.
Beauty.
Beauty.
Agathon. Can we see the word cloud?
Absolutely.
Remember, Bill and Ted's called it Socrates. So.
Right,
That's true.
Socrates, exactly.
Aristophanes. Phaedrus. Boy. How about those? How about those clusters?
Okay, let's take a peek at the clusters. There.
Oh, looks like giving, donations. Okay. Love, beauty. Oh boy.
I think if I was wearing a toga.
Yeah, that's about as far as I got was Greek.
Okay, all right. Name a philosopher.
Well, other than Socrates, Plato.
Plato, very, very good. And what's the work?
I know.
I can't say I've read any Plato.
Okay.
Is it Plato's Republic?
It's Symposium. Yeah. So this is good. So we're gonna go with 5 points for you, Ross, because you got the.
I'll take it.
Yeah, totally.
I tried to help.
Okay. All right. So work 8. We're back to Kamal. How are you doing, Kamal?
Ready for it?
Okay.
Oh, that's easy.
Okay. All right. So might not be easy for everyone. So say it as a question. So.
What is Sherlock Holmes?
And the author.
Who is Arthur Conan Doyle?
Conan Doyle, yeah, very good. 15 points for Kamal. Well done.
I get all the easy ones.
that was impressive,
Very good, very good.
especially the author.
It's really good.
Yeah, that's really good. Okay, so let's go to work number 9. And I'm going to keep an eye on the time here. I'll ask Julian to keep us on
Who's
time.
on deck,
Julian,
Chuck?
Huh?
Who's on deck for this one?
Oh, okay.
I think it might be
so
me.
It's Wendy. So
Okay.
Wendy, you're looking at work number 9 now. Yeah.
Isn't Scarlet Letter a novel?
Very good. Yeah, you got. So what is the Scarlet Letter? Very good. And can you get the author?
No.
Okay. Anyone want to help?
I know this. I totally know this. It's the only essay I got 100% on in high school.
Awesome.
But
okay.
Drawing a blank. Sorry. Can't help you, Wendy.
The last name of the author is the same name that is a famous tree.
I had oh really?
Yeah.
I think I had a buddy throw me a bone here. Is it Nathaniel Hawthorne?
Yeah, very good. Very good.
Nice.
Yeah, super.
I thought it was Bill Eucalyptus, but I was wrong.
Okay, so we'll give Wendy the full amount. That's 15. Okay. And I think it's Jeff next, right? If we're doing round robin.
Ready for it.
Okay, and we'll give you book number 10. All right. And
Ivor
just ask.
Lawrence.
Yeah. So ask.
Romeo and Juliet. Yeah.
Oh.
What is Romeo and Juliet by Shakespeare?
William Shakespeare. Awesome.
William Shakespeare.
Yeah.
Yes.
For 15 points.
That was fast.
Yeah, that was really fast. I didn't even have
Wow.
to go down to the word cloud. Okay. So back to Rob, and then we'll do a lightning round.
Okay.
So Rob, you're going to look at. We must be at book 11 now.
Mm-hmm.
Okay. Here we go.
Come on, easy book.
I wonder what makes them easy and hard.
Comic books.
When the title's in the name of the, right?
Yeah,
Title's in the phrase, that helps.
that's right. Yeah, I should have put stop words in for everything. I don't know if the audience knows what a stop word is, but I could have suppressed certain terms or words that would give it away too easily. So I think we're looking at number 11.
Yeah, these are kind of basic. Can I see the word cloud?
Yeah.
Oh, I see Plato's in there. Would I go back to Plato's Republic, like I said before?
Very good. You got it. Yeah.
Wow,
Plato's
bravo.
Republic for 15 points. Very good. All right. The next one here, we're going to call a lightning round. And so you should all have a white piece of paper. And when you think you know the answer to the book, just raise your paper up so I can call on you quickly. So it's kind of like a timer thing. So do you have your white pieces of paper?
Yep.
Okay, very good.
We're ready.
All right. So we'll look at work number 12 here. Okay, I'm going to reveal it now.
Well, that doesn't help.
I got it, Chuck. I got this one because I memorized this in middle school.
Oh, you did. You did. Okay, so you
Yeah.
raised your. I recognize Jeff. Okay, Jeff.
So this is the Raven by Edgar Allan Poe, or what is the Raven by Edgar
It
Allan Poe?
sure is.
Wow.
It sure is. How did you get that?
Well, I memorized this in, I think, 7th or 8th grade. So once upon a midnight dreary, while I pondered weak and weary over many a quaint and
that's
curious
right.
volume of forgotten lore.
Oh, very good.
Thank you,
Very
Wow.
Mr. Seiplich, for helping me win this game. I think it's the only time this poem has ever really helped me in
Yeah.
life.
And quoth the Raven.
Quoth the
nevermore.
Raven and nevermore, right?
Yeah, very good. Very
Yeah.
good. Okay, let's do another one, and Julian will probably break in here in a couple of minutes. But so let's do one more lightning round. We'll look at number 13.
You were ambitious, like we were going to get a lot of these books.
Yeah, actually, you've done very well. All of you have done really, really well. So now this one is in honor of mathematicians and physicists everywhere.
Ooh.
So you should be thinking about your science classes, maybe a physics class. Okay, we'll move down if that's helping. I don't know if Brad is still on the line. I bet Brad could get this one.
Is this supposed to be a literary work?
This is a science work, actually.
Thanks.
Is it Optics by Newton?
Ah, you got it. That is amazing. That is amazing. Well done, Kamal. So Kamal, it's the.
Kamal, did you memorize that too?
No, I did not.
Wow. That's amazing.
All right. You all did really, really well. Let me tally this very quickly. So I need an assistant here. So 15.
Maybe the next game we'll do is algebra.
I know, exactly. So it looks to me like Rob, you may be the winner here.
You know, in all honesty, I have to give back 5 points because you gave me 15 for the first one. I didn't name the author.
Okay, well then that would make it probably a tie then. Well, I'm just going to say everyone wins here. You did a great job.
Well, thanks, Chuck. This was fun.
Yeah, I'm really
times,
glad
good
that
times.
you're all really, really good sports. Hopefully we can play this. And I love the idea. Who was it last night? Someone suggested that we should try comic books.
That was me.
I want to let you know I did actually dump some comic books in here, and it was too easy because you know the Batman comic books, the giant,
the boom,
you know, boom, bath.
Yeah.
You know, you could tell immediately. But we should probably experiment with that if we ever get asked back. All right. Well, thank you everyone for participating.
Thanks, Chuck.
I'm going to turn it back over to to Julian at this point, and thanks for playing.
Thanks.
Thanks.
Fantastic. Thanks so much, Chuck. There was a few questions that came in during the broadcast. So asking about if you would be willing to post your
Thanks, guys.
data set and
Sure.
some of your scripts. And yeah,
Oh,
'cause I
very
think a lot
happy
of
to.
people are, yeah, I think people will be curious to see exactly how you did some of what you did. And yeah,
No, I'd be
we'll
happy
have you
to.
back on and you can take us through that. Thank you so
Okay.
much, Chuck.
Very happy to. Okay, bye everybody.
Thanks, Chuck. In our next segment, we have Artie Mindell back to give us another mindful moment.
Hey everyone, my name is Arti and I'm coming to you from my home in Baltimore, Maryland today. And this is your mindful moment. It's an opportunity for you to pay attention to the present moment on purpose and without judgment. So today we're going to do a little bit of movement followed by some breathing. So come toward the front of your chair and bring your feet flat to the ground. And we'll begin by inhaling our arms up overhead. Bring the palms to touch at the top. And then you're raising your head as well at this inhale. And then exhale, lower the arms down, palms face down, and then your gaze comes down as well. So let's do that 3 times together. So inhale, lift the head, lift the arms, touch the palms together. Exhale, lower the head, lower the arms. 2 more times. Inhaling and exhaling. Last time, inhale and exhale. And this time, inhale the arms up overhead, look up, bring the palms together, but exhale and bring the arms into like this goalpost position or cactus arms, sometimes people say. And then inhale, reach the arms up overhead, and then bring them into the cactus arms on the exhale. So we're going to do those 3 times together. So inhale, exhale, inhale, and exhale. Last time, inhale, and exhale. Now we're going to put those 2 movements together. We're going to combine them. So from here, inhale the arms up overhead. Exhale the arms into the cactus arms. Inhale the arms up overhead. And this time, lower the hands and arms. Inhale, arms up. Exhale, come to cactus arms. Inhale, arms up. And then exhale, lower all the way down. Last time like this, inhaling up. Exhale, come to the cactus arms. Inhale up. Exhale, lower all the way down. Lift the head up. And then just notice how you feel for a moment. And from here, extend your arms out as wide as you can. Hopefully you have some space around you. Inhale here, and then exhale, bring the arms with the right arm on top, and then give yourself a hug. Grab onto your shoulder blades back behind you. Take a deep breath in, feel the stretch in the upper back. And exhale. And then slowly turn your head to the right. And then slowly turn your head to the left. Now we'll do that with breath. Inhale and exhale, turning the head. Inhale here. And exhale, slowly turning the head again. And bring the head back to center. Release the forearms and then wind the forearms together here if you can, bringing the palms to touch. If not, bringing the back of the hands to touch is just fine. So inhale here with the forearms wound up like this. Sit up tall. Lift the elbows to shoulder height if you can. And take a deep breath in. And exhale. Now release the arms out wide again, and we'll do left arm on top this time. So left arm comes above right arm, grabbing onto the shoulder blades. Take a deep breath in, and an exhale. And this time turn to the left. Inhale here, and exhale, turning all the way to the other side slowly. Inhale, and exhale. Inhale, and exhale. And bring your head back to center. It doesn't matter if you got the breath pattern exactly right. It's all good. And then just roll the shoulders up, down, and back. Let's do that with breath. Inhale and exhale. Great. And then just allow your arms, hands to rest on your thighs. Close your eyes if you can. And we'll just pay attention to our breath for a couple minutes. Just notice where you feel the breath. Do you feel it at your nose? Perhaps you feel your chest rising and falling. Maybe your belly goes in and out. Bring your attention to the back of your body. Feel the breath there if you can. And just breathe. Taking a break, letting everything relax. Just let go. And see what you notice. And then when you're ready, just gently open the eyes. And see how you feel. Thanks for joining me for the mindful moment. Stay curious and be present. See you next time.
Thanks so much, Artie. In our next section, we have Rob Levency back with us to take us through Control Chart Builder in JMP.
Hello, my name is Rob Levency, and I am a systems engineer for JMP for the federal space. And today what I want to talk to you about is, oops, here. I don't know, am I sharing? I seem to have lost my sharing here.
You are, Rob. Yeah,
okay, great, excellent. Okay, so I'm here today to talk to you about Control Chart Builder. And let me give you just a little bit of an introduction. So I worked in quality, I worked in research and development, product launch, which all involve processes for the majority of my career. And I wish I had this tool for many years, but now we have it. Bottom line, what I'm going to show you about is explain what a control chart is and where it came from. Demonstrate how to make and use a variables control chart for container filling process that I have. I'm also going to show you how to apply a control chart for a document review process. And the whole time, we're going to examine the functionality of the control chart builder. So here's a thought to start with. Have you ever thought about how billions of people have phone calls made around the world every day predictably? And this has been the case for many, many years. Well, we all can thank Walter Schuhart. The next time we make a call, Dr. Schuhart developed a method to monitor processes while working at Bell Labs. His innovative charts really allowed technicians and engineers to figure out what's the normal variation from special causes and make huge improvements to their processes. And control charts can be easily created with JMP in the control chart builder to really help anybody make a process perform at optimal levels. Okay, so we have to have a little setting here. This type of chart is a variables chart. It's something that's used for measurable data, something that's quantifiable. So we have this team, they're responsible for a high-speed container filling process. And they've been experiencing unpredictable issues with fill amounts, which is a bad thing. And their measurable is they weigh the weight of material that's in a container, and they do quality checks once a shift, and they do about 5 random pulls, and they measure what the fill weight is. And so a variables control chart can really help them better understand their process variability and disclose special cause variation. So I'm going to pull this up, and here's our example, and we have weight here. So all I have to do is go into the Analyze menu and find our Quality and Process tools, and the very first option is Control Chart Builder, which is awesome. So this looks at, if you've used Graph Builder, this is a very similar interface, but it's a little bit different in that we first have to have some kind of response. In our case, it's weight, and here we go. Now, by default, when I pull in that data, JMP is going to think that, okay, I want to make a chart for each row. So that's an individual chart and also a moving range. So how much each weight changes to another. Well, in our case, we have sampling. So we have 5 samples that we want to look at how the average is changing over time. Super simple to do. All I have to do is pull the sample group down into the subgroup area, and voila, I get a chart that shows how the average is changing over time. So that's what I have on the top. And at the bottom, I have a range chart. So that's how much spread I have within each sample. Now I can also change that to a standard deviation chart using some of these points over here, where I can really get in and change the options however I would like. But one of the things I want to do is I want to see, maybe I'm not that good at these charts yet, and there are some tests that are embedded, and you can see we have some warnings that we can pull in here kind of manually. But what I like to do is I just right click on here, I go to warnings, tests, and I want to run all of them. So what JMP does for me, it automatically finds those areas that could be special cause variation. And if I hover over, like this number 1, this gives me the example that this point is out of the normal range of random variation that I would expect. And so that's what these red limits are, these control limits, 3 sigma. And you notice I have some other points over here. If I hover on those, this is telling me I have 6 points in a row that are either steadily increasing or decreasing, which tells me we wouldn't expect that to happen at random. And you can see it's kind of a round robin. I have actually more than 6 points, so it's warning me 3 times that I have that issue. So that's great. One of the things that I did is I went back to my subject matter experts, and we reviewed the process, looked at all the documentation, and we actually we did some improvements, and I was able to run some more data after improvement. Okay, so we're going to see that. And what I've done in my data is I actually have phases. So I can pull this in the top, and now I can see phase 1, which is where we studied the process as is, and then the improved process. So we can really quickly see we didn't change the average, which is good, but we dramatically reduced the amount of variation that we can have when we go out 3 units to standard deviation, which is very good because, by the way, I really want to hit 510, I think this is grams, as a minimum. So before I had some defective product that I could be making. So we've made huge improvements. Variables control charts, very easy thing to do. And there's lots of more detail that you can dig into the documentation in the help area. I'm going to go into my attributes, and then I'll ask about questions. So we have another process. In this particular case, this is not a machine process. This could be a process anywhere. This is a process based in the pharmaceutical industry. So you have this highly regulated industry. Everything has to be documented. And so we have these document packages for manufacturing and for packaging. We have them for other things, but those are the 2 things we're focusing on. So the documents are made in the site that the process happens, and they get reviewed by their on-site quality people. And then those get passed on to a quality control group that they have to look at the documentation with the tests from the laboratory and make a decision whether this batch can be released and sent to product for customers. And what they're finding is leadership is noticing they're not having predictability in how long it takes to get products released because a lot of the initial reviews have mistakes in them and then they have to be redone. So they're thinking, you know what, a control chart could really help the team understand the variability in this process and solve the problem. So here I have documents, and you can see we have either a document package that went through, passed both checks as good, or we have document packages that were flagged by the second auditors as having a discrepancy and had to be fixed, okay? So we go back, quality and process, and we go to control chart builder. Now, you might think, well, I have to make some adjustments because this isn't measurable data, but JMP is able to understand the variable because we have a discrete variable type. It will automatically shift to an attribute charts. There's a rare event chart as well. We're not going to have time to cover that. I ask you to check the help documentation and check how that can work out. So I'm going to pull this status into the Y, and then I'm going to bring my day into the X. And now I can see I get a little bit different looking chart than what I had before, but it's somewhat similar. And the one thing that you might see is this automatically has converted into proportions. So on average, the overall average, about 34% of my document packages don't pass, and they have to be sent back for fixes. And that's why we're not releasing product on a timely basis. The other thing we look at is we look at this over the day. This is a month. And our subject matter experts are noticing that, wow, these things are necking in. What does that mean? Well, as you have larger numbers per day, your limits can shrink. So what this is telling me a couple things. Days 6 and 7 are always a higher number of documents, and that's where we have a lot of errors. And so when we studied, we found out that that happens to be Saturdays and Sundays, because this is around the clock operation, but we don't have as many auditors on staff on Saturdays and Sundays because they're weekend shifts. And by the way, during the week, they kind of hold back on documents and they push a bunch of them to the weekend, and then they have fewer people to review more documents. That doesn't work out very well, as we can see. So I'm going to go back to my data. I actually have some phases in this one as well. So we addressed the problem. I'm going to pull my phase in here. And this is a great way to show leadership before and after. And what we were able to do is level load the system. So we have the same number of auditors and the same workload every day. And lo and behold, we were able to reduce our overall average of about 34% defects in documentation down to about 10%. So we made huge improvements, saved a lot of time and money using the control chart builder. So I'm going to stop at this point and ask if there's any questions.
Yeah, Rob, there is one. I don't know if you can see your Q&A panel, but I'm happy to read it off to you.
Yeah, if you wouldn't mind.
Yeah, so one of our attendees asked, why when using Schuhart type control charts does JMP display control limits for the X bar chart when the range chart shows inconsistency?
Well, I always looked at the range chart first, because that really gives you your first indicator of issues. And then I look at the average, or at the averages chart. So it is a good point. Sometimes those range charts, the calculated limits, you need to adjust a little bit. One example is we used to bump the range, the lower limit of 0 up a little bit, because sometimes 0 might mean that it was a measurement device that didn't read. So, but that is a good point. I always look at the range first, and then I look at the average afterwards.
Great.
All right. So we might as well close this up. So to summarize, control charts quickly identify regular variation from special causes. You always need to involve your subject matter experts and good process documentation to explore those causes, make improvements. And the control chart Builder in JMP is a really fast and easy way for teams to make big improvements in processes. So you want to make sure that you get to this. Something that moves nice and smooth with no issues. So thank you very much, Julian, and have a great day.
Fantastic. Thank you so much, Rob. And for any of our additional questions that weren't not answered during this segment, make sure that you visit us on the community, because we'll make sure to address those. And I'm sure Rob has some additional resources he'd be willing to share with us for anyone who's really interested in the control chart builder. Great. Thanks again, Rob. Our final segment, we have Pete and Mary back to act out real life situations where a JMP tip is actually the solution. So that brings us to today's tip of the day.
Hey, this is Pete and Mary's tip and trick. So Pete sent me some emails, said he had something really exciting he wanted to share with me. So I just scheduled some time, and I'm excited to see what JMP has to share with me. I'm excited to see what Pete has to share with me around JMP. Take it away.
Yeah, so I was sharing with Mary this data view, which I think is awesome. And maybe some people knew about this, but I'm a slow learner, so it took me a while to find this. But Mary, here's that data table we were playing with a while back with some of the process data. And
Right.
I was talking with Carl, you know, the shift leader of Shift C, and he wanted to just look at the Shift C data.
Yeah.
So here's a quick way to do that. So I can just select those matching cells.
Yeah.
So I right click and select the matching cells. And now over here, I have all 359 of those rows with Shift C. And I can just right click on it and go data view, and boom.
Oh, that's what you meant by data view. I thought maybe it was something with Graph Builder or some other visual tool.
You never know with me. It could be anything. So
That's true. That's true.
But one of the coolest things about this is it's actually a linked set. So you see here, it says linked subset.
Yeah.
And so what that means, if I go through and I change something, so let's just recode this and actually call this Carl shift instead of just
Oh, he's gonna love you for that.
oh yeah.
Yeah.
So you see it changed in that subset, but it also changed back here in the data.
Oh, wow. Oh, that's pretty neat, Pete, because then you can do some data cleaning and manipulation and work on adding things, because if you added a new column and different things, it would actually go between the two tables.
Yeah, yeah,
All right.
it's super
Make sure
handy.
you send Carl that data table with his name in it.
I will.
Now, can you do the same with exclude and hidden?
Oh, great call. So let's say we weren't interested in this specific query. We didn't really care about them.
Okay.
We're not going to use them going forward. So we'll hide and exclude that data. So this is a great way to not have it in the analysis, but still not delete it.
Yeah.
So I select this hidden, excluded, selected. These don't have to be selected. I can deselect them and just go to say that excluded and then go data view.
Oh, you know what's really cool about this, Pete? If you had outliers, you had some oddity in your data that you wanted to exclude or highlight, you could actually go create the data view and go explore it outside of the larger data set. Oh, yeah. Pete, this is cool. This is great.
I'm glad you appreciated it, Mary. I think
I'm glad you didn't waste my time. But this tip and trick is great. So a data view is a view from selected, excluded, or hidden, and allows you to create a secondary table and manipulate and explore that data.
Yep.
So I like it as a way to drill down. Nice.
Absolutely, and keep in mind that it's linked like that, so it will remember any changes to either the main table or to the subset.
Excellent. So. Well, thanks, Pete. I got to run, but thanks for sharing your tip of the day here.
Awesome. And this has been the JMP On Air tip of the day with Pete and Mary. We'll talk to you next time.
Yep.
Bye-bye.
Thanks so much, Pete and Mary. And if you have a tip or a trick you'd like Pete or Mary to act out for us, make sure to submit it at community.jump.com/jumponair and go ahead over to their segment page where you can make any kind of suggestions you want. In fact, if you have any suggestions for the show overall, make sure you find us there. You can submit on the show suggestions page or even on any of the full episodes. And of course, if you liked any of the episodes and you want to share them, make sure to link those over to your colleagues. Follow us on all the social media channels. We have a lot to share with you, and we'd love to stay connected. Certainly check out the program guide and join us Friday. Jonah Berger will be on the show in our featured author interview, and so we're really looking forward to that. Share us with your colleagues. The link to share is jump.com/JOA, which will take them right to the program guide so you can share with them what we have coming up and so they can subscribe for themselves. We can't wait to see you Friday. Until then, we hope you stay safe. We hope you stay healthy. We hope you stay close, even if you have to keep your distance. Take care, everyone.